When did you go to Brazil?
Oh, I left the U.S. on 6/7. That was how we've been working it in. Yeah, June 7th, if you were curious. So here we go, Chapter 1. We're jumping right in. We're going to start Chapter 1. Our overarching theme for roughly the next 10 to 12 days of class will be functions and their graphs. All right, so as we are maturing mathematically, one of the things that we're going to start learning, I know that if you took my geometry class, you learned a lot of the really formal shorthand, because I taught a lot of the really formal shorthand. If and when I write something on the board that you just don't know what it means, you don't recall, tell me. I want you guys to learn the shorthand because it saves a lot of time, but I think that just by using it is how we're going to learn it, rather than me saying, here they all are. Let's just practice with them as we go. So 1.1, we may get through all of this today, and it will be a piece of cake. This just indicates Chapter 1, Section 1. Our focus is going to be on this lovely idea of rectangular coordinates. All right. So there's a lot of information that we can just try to grab from here. I have one example that I'm going to use just as kind of gauge to see how much I actually have to write, because I think you guys will know it all. Just so you're aware, these will be moving to the back board next week, but one of the things that Mr. Allison has asked us to do as teachers this year is, anybody in here ever had Ms. Hanish walk in and ask you what you're learning today? Yeah. And how you know you've learned it? I have no idea how to answer the second part. I wish I did. But apparently you guys are supposed to learn better if I write this on the board. So here it is. Today, by the end of today, what I hope you can do, and I think you might be able to do, is plot points, use the midpoint formula, and use the distance formula. That's our goal for today. That's what you can do by the end of today. That's the goal. So I have a quick challenge that will help us decide where we're going to jump in. Before we say anything about these, there's some key pieces here. Coordinate system that we use, it gets its name from Rene Descartes. Anybody remember the name of that cross that we use? It has an X and Y and some other pieces. What plane? What if we don't want to use the word coordinate? The Cartesian plane. Coordinate plane is the same one, the Cartesian plane. Anybody remember the legend to how this happened? You want a legend. It's like, I think it's a real story. It is a real story, but it's like lore. It's math lore. You guys will remember it, I think. Okay, so here we are. Let's say we're 1600. Okay, and here I am, and I'm a mathematician. There's two very distinct fields of mathematics. There's geometry, which is done on flat surfaces, planes, and things like that, circles, if you will. And then there's algebra, which is all the analysis stuff, factoring, solving, those things. Up until the 1600s, the graph of y equals x squared didn't exist. That idea was just nonsense. X squared wasn't a graph. X squared was purely an analytic algebraic tool. Until famous mathematician, scientist, philosopher Rene Descartes was laying in bed one day, and the lore goes as follows. He was laying in bed and he had a tiled ceiling like this. Okay, so imagine you're just laying there and you're thinking about math because it's what you do, you're a nerd. And here you are, and I notice all of a sudden that there's this grid system up here. And I see a fly land here, and I start to think, gosh, could I tell somebody where that fly is without really having to point to it? Could I just give them a location? Like maybe go this many tiles this way and this many this way. And maybe we'll call it X and Y or something like that when we deal with it. But by laying in bed and seeing a fly, he had a thought that had never occurred to mathematicians before. He figured out that he could take all these algebra ideas, all these points, ordered pairs, everything that we see in algebra, and he could look at it in a geometric viewpoint on a graph. That was a huge change in mathematics, because now instead of having geometry and algebra, it came to this larger field and say, hey, look, we have this big collection of math. We were able to solve problems in geometry that we couldn't before because we had this new approach in algebra, because we could move between the two fields easily. Okay, the guy responsible for this is Rene Descartes, and he developed and started implementing our very first topic here, the Cartesian plane. I'm not going to count it as a vocab, Cartesian, only because Descartes, it looks like Descartes, but the Cartesian plane. And whether you call it the Cartesian plane or the coordinate plane or just the plane in an algebra class, everybody's going to know what you're talking about. So here's my challenge for you. Without me having to just talk at this at length. I want you all to sketch a rough plane here. Now, if anybody is crazy about this, protractors got about 1 billion of them. So, I will remember where they are eventually. If you want a protractor, pass this box around. There's brand new protractors everywhere. There's 10 in each box, so we won't get that many. Oh. You get that one. You don't have to use that. I don't care if you use it in your notes and stuff. Like, it's up to you. When we get to circles, I have some cooler ones too. All right. So here we are. I want you to identify with your neighbors. I'm going to give us like 3 to 5 minutes. I'm going to write a bunch of stuff here. I don't need this recorded. I'll just remind me to resume here in a second. On your Cartesian plane that you have in front of you, what I would like you and your neighbors to do over the next 3 to 5 minutes is identify each of the following. On this, I want you to label a bunch of stuff. Okay. What do you guys remember about the Cartesian plane? What might I ask for? Which key features of the Cartesian plane do you think I'm going to ask you to find? Hit it. The origin, yeah, for sure. I want you to find me the origin. Now, whether you physically label it and say, hey, this thing is the origin, if you can just tell me what it is, I don't care if you write it here, as long as you know it. Other things, just shout them out. Axes, but I agree. Or anything else? Quadrants, love it. And then I want you to also, on top of or beyond quadrants, I want you to find me a point in each. So find me a quadrant 1 point. Tell me any point, don't care what it is. Plot it on your thing. And then beyond that, last little piece that I want is going to be a point not in a quadrant. I don't think we'll take 5 minutes. If we do, that's okay. I'm going to give you guys a second. All your pictures will probably look different with the exception of whoever you're working directly with, if you are. I want you to find me and be able to tell me and your classmates, where's the origin, what are the axes, what are the quadrants, what are some points in each quadrant, and what is a point that's not in any of those quadrants. I will give you a couple minutes. I'll come around and eavesdrop. Bad answers. There's right and wrong answers for this, but there's no bad answers. It's me. I want a point not in a quadrant, and because I told you guys you had to do another one, I'm going to use red to put these. Here's a point that's not in a quadrant. Fantastic. Cool. Number 3, can you give me another name for what I just did? I labeled something. Origin. Everybody cool with that? Yeah. Awesome. What could you tell me about any of the other ones, number 12? Who's number 12? Jamin, can you tell me an axis or a quadrant or a point?
The x-axis is the horizontal.
Love it. X. Awesome. Give me something else. Jamin, it's you again, just for the record. It's real. The y-axis. Love it. It is not 12 again. It's number 1. Give me something else.
A point in quadrant 1 is
1, 2 is in quadrant 1. I agree. That's what I was expecting people to answer. Weisha, can you tell me how you answered that? Because you're not the only one, but I like that as well.
Oh yeah, I just like for quadrant 1 I put positive, because the x and y are both positive.
And this is a generalization. Love it. You're correct. You gave me like a specific example. Love it. Correct. Okay. Which quadrant is this? Quadrant 1. Okay. So I'm just going to put a big I right here. All right. Addison, hook it up. What quadrant is this one? Give me a point there. Or what would a point there look like? Okay. So I'm just going to focus on the negative part. And the second number was what?
4.
Perfect. Cool. Ugly. Hate it.
tried writing it for one.
Yeah, it's my brain just wouldn't slow down. Which quadrant is this, Matilda? Right here.
Fourth quadrant.
It is indeed. What can you tell me about a point in the 4th quadrant?
Or it's positive.
Fantastic. And Abijah, quadrant?
3.
3. And what would a point look like in here?
-.
Love it. Okay, hardest question out of all of them, I think. I want another point that's not in a quadrant. A non-quadrantal point is how you would say that, but the word is ugly. Anybody is free to just shout it.
Anything on a line, on the X or Y axis.
Any point on the axis. This is not in quadrant 1 nor quadrant 2. It's a non-quadrantal point. Okay. Honestly, thumbs up is yes, thumbs down is no. There should be no in between. Do you need to practice plotting points? Okay, I don't want to make you plot like 5 points on a plane. Yeah, I know that's confusing when I throw it out there. Okay, we're not going to plot points together if you guys are cool with that. Everybody know how to plot points? Cool. Which of those letters comes first? Okay, fantastic. All right, so check it out. On the Cartesian plane, any 2 points that aren't the same point, they're in different locations. That's what it literally means to be a point. So, same thing. I'm going to leave this one blank for just a minute. I will come back. This is our main topic. You guys seem to have a pretty good understanding of the Cartesian plane. I'm going to sketch only in quadrant 1 right now. And for this, like, you can use your straight edges and stuff. You don't have to have them perfect. They don't need to be great right now because we're just using it as review material. I'm going to pick 2 points in quadrant 1. And so here's quadrant 1. I can see it. Jamin, give me any point in quadrant 1. That's the natural that everybody always gives. I agree. I'm fine with that. 1, 1. Rodeo, give me an estimate of this point right here. 6, 7. 5, 3 also works fine. 6, 7, I don't think it would work unless we change this. Anyway, all right. I have a challenge for you. Those are 2 different points that are separated by space. There's space in between them. It means there's a distance between them. Can you find me the distance between those 2 points? I want you to try it. You might have to take a few different angles to be right. Cool. Give it a second. Talk with each other. I give you 3 obnoxious words there to use as a very specific point or direction to go with. You should use a right triangle somewhere in what you know about right triangles. I'll give you a moment. I'm seeing a few different approaches. Anybody looking at this going, gosh, I know the distance formula exists. I don't remember what it is, though.
Yeah.
Anybody feel like you remember the distance formula right here, right now, without looking at a resource? Okay, cool. I do, but I don't really. I remember something else. I want you to finish this for me. Geometry. What's a squared plus b squared?
B squared.
And that's what? The Pythagorean theorem. And it tells me that the 2 legs, the shorter sides of a right triangle, if you take them and square them and add them up, it's the square of the hypotenuse. So here's how I remember the distance formula. And lo and behold, that's actually the name of this. We're looking at the distance formula. Now, I'm happy to use these exact points if you'd like, or we can use generic points instead. Do you want the concrete, these 2 points, or do you want to call this x1, y1, and x2, y2? Does it matter? Can we go concrete and then just go 1 step further and expand and see what it would have been? So let's do it. Okay, I'm looking for this distance right here. Now, when I view problems like this, I don't remember the distance formula. I think memorizing stuff is not how math should be done necessarily. I'm going to make a right triangle. Does it matter if I do this right triangle in red or if I do this right triangle in blue? Are they the same? Are they congruent and similar triangles? Yeah. I naturally want to work with the blue one. I saw a couple of people naturally want to work with the red one. Either way, we're going to have the same method. It just might be flipped in the way we label these points. Okay. Is this bottom piece, is this a horizontal line?
Yeah.
So what do you guarantee the y value still is?
Wait, why?
Is everybody okay with saying if I didn't rise or run, I still have a height of 1? What's the x value of this point here? Because it's just dropped straight down from this, right? Okay, so now we have a triangle with 3 specific points. How do I identify the hypotenuse of a right triangle? Like, I can see which side it is, but what if it were maybe not quite as obvious? Everybody know which side is the hypotenuse? The long one. What angle is it always opposite from? The big one, or the right angle. Okay, so big challenge now. Could you find me, like, diagonal distances are hard. Is this distance hard? To go from 1 to 5, how would you find me how far I've gone? you would subtract. And it doesn't even matter the order that you go as long as you use absolute value. 1 minus 5 is negative 4. The distance is 4 when we take the absolute value. Or 5 minus 1. Everybody okay with saying this side has a length of 4? What about this side? Because it went from 1 to 3. Cool. And now I'm just going to call this C right now. From what you've done in geometry, I think that I know for a fact that C squared is equal to what? A squared plus B squared. In this case, it happens to be 4 squared plus 2 squared. Are we all on board? Okay. When I inevitably skip too much work from line to line, tell me. I'm happy to annotate because everybody's at a different place for mental math. Okay. Gosh, what's 4 squared? So C squared is 20, which means how do you undo a square root? Gosh darn it. How do you undo a square?
I didn't even notice at first.
Okay, normally, super important algebra idea. What normally goes in front of something when you introduce a square root? Plus or minus, positive or negative. Why am I not going to consider even the negative here? Because it's distance. It's going to be positive. So I know it's a square root of 20. I'm okay with us stopping here. If you went further and called this 2 root 5, cool with it. Not my focus right now. Okay, I just got C as root 20. Does this look familiar?
Yeah.
Did I ever use the distance formula? Well, you say that, but let's dig into where this came from real quick. I want us, same picture. I'm just going to do this a little bit differently. Let's call this x1 and y1. And this one is x2 and y2. And I just want to see, what did we really do? I have 2 points that are labeled like this. Let's see what actually happened. What did we subtract to get the 4 squared?
5 and 1.
And what did 5 and 1 correspond to?
The x's.
They're both the x's, right? Like, we just subtracted it. Now, it doesn't matter if I do 5 and 1 or 5 minus 1 or 1 minus 5, because the Pythagorean theorem says I'm going to square it. So it doesn't matter if it's positive or negative there. So let's just look this out. The distance, which I'm going to call d instead of c here, looks like, well, we could just take the square root at the beginning instead of the end. It's the same stuff. And you just told me that that first piece was x2 minus x1. And we square it, right? And then what do we have to add to this? What's this? This was 2. But in our generality here with y1s and 2s, how do we get 2?
Y2 minus Y1.
Oh. This is the distance formula. If you can remember the Pythagorean theorem, which I guarantee everybody can, you can remember the distance formula. They're the same thing. We're just skipping over the step of having to physically draw the triangle and saying, look, this is all we really calculated. Forget about the lines. Let's make this easy and fast for ourselves. Okay, distance formula. We will use it. There's one more that we need to worry about. I'm going to use the same picture, or is yours too muddled and you want a different picture? Ooh, let's try it without a picture even. This is going to be neat. Before we move on, a couple things I do want to check with and just really emphasize. Does this order matter? No. If I do x2 minus x1 here, could I do y1 minus y2 on the second piece? This one I can, because what happens to it? It squares. It turns out positive anyway. When you type these into a calculator, I would always do larger minus smaller. Like, I would never let a negative number be squared, because if you forget parentheses, you're going to burn yourself on it. Just always type in the positive number. If it's negative 6 squared in this situation, just type in 6 squared. No need for the negative. It doesn't need to be there. That's weird. All right. So from this, there's a little expansion on the distance formula. If I'm asking about distances, could I ask about half of that distance? Sure. And kind of fits within distance formula, but we better define midpoint and give ourselves that nice midpoint formula. Okay, I'm going to use a shorthand here. What do you think MIDPT is for? Oh my, midpoint. Yes. Formula. Okay, how many of you remember learning about midpoint formula? Not what it is, just how to, like, you learn about it. And you might not, that's okay. That was like second or third week of geometry, realistically. Who remembers what exactly the midpoint formula is? check it out. We're going to do it in two directions. And again, you don't have to memorize the formula as long as you understand what the concept says. So check this out. I'm going to draw 2 lines here. And I'll put them on the quadrant, I suppose. They don't have to be, but it's nice to see it in generality here, or in the plane. Real numbers, or can I just use x's and y's? Okay. Here's point 1, x1, y1. And then over here, arbitrarily, I'm literally not even thinking about where I'm putting it, x2, y2. Okay. Does that segment have a length? Could that length be cut in half? So the midpoint exists. I know it exists. They're not the same point. There must be somewhere between them. Now, I don't want to have to just rely on remembering a formula. But check this out. You don't need to, but could we draw a triangle with these if we wanted? And I'd always rather work with vertical and horizontal lines than diagonals. They're easier to deal with. So let's say I wanted to introduce a third point, and I'll do this in a slightly different color. And I wanted to do it right here where these two meet. Help me find this ordered pair. What would the x value of this new third point that we're adding be? x2 is the x value because it's just straight down from here. And how about the y value? y1. Okay, so it's really not a whole lot different than what we just did with the Pythagorean theorem stuff. In fact, I will even connect the hypotenuse here just so it's almost the exact same picture. Now, if I wanted to find the midpoint of that diagonal line, let's just think about this. Every point that we ever use has 2 components, 2 parts to it. There's a comma in between our numbers because the first number represents the x component, great Jimin, and the second number represents the y component. I'm going to use that word specifically because we'll see it later. 2 components or parts. Does a diagonal line have some amount of x component and y component? Always, right? Any line that you give me. So let's forget everything. For now, don't erase yours. I'm just going to imagine it's gone. How would you find the middle of that one? Just the bottom one, between those. So you do x2 minus x1. So that's the distance between them. And then you would divide it by 2, I assume. Okay. There's another way that we could think about this. That would work. It would do that. If you subtract and divide by 2, will it work? x2 minus x1 divided by 2. Will that work? Well, what if we just think about it as a number line? I want to know what's right in between them, or the average of these two. Could you add them up and divide by 2? Now, the other way to do it, you're not wrong. And if you're thinking, why didn't that other one work? If I took this distance, let's say it's a distance of 10 right now, and I said, okay, let's divide it by 2, and I said, oh, the midpoint is 5 away. But then I just go out to 5, I might wind up here, depending on where I am on the coordinate plane. You would have to say, start here, and now go 5 over. And then you have to tie this to another part. Or, instead, if we just said, what's the average of these numbers, we wind up right in the middle, because there's only 2 numbers. We're doing the same thing, but if we do it the first way, we have to start here and then count over from there. Do you understand what I'm saying? It's like for real? Okay, all right. So as we're looking at this, I think that we reasonably could identify this point right here, right in the middle. And I'm going to mark it. This point, if we wanted to, I know that its x value would look like x1 plus x2, and I could just divide it by 2 to get the average of them. And I'm only looking at the x right now. If we wanted, we could say it's y1 because it hasn't changed, but that's all I'm looking at, just the x. Could you find me the middle of this one using something similar? It's the average between which 2 points? So this one would be the y value would be y2 plus y1, and it's just divided by 2 again. We could find the distance and figure out how far up we have to jump to get to half of it, or we could just find the average. Is that still cool? Now, that would identify this point. We now have a midpoint in the x component, or the x direction, and we have a midpoint in the y component. When I put them together, and I say, hey, let's find the middle of the x and y, but write it in one spot, what did we just find? Did I find the midpoint of the actual segment we were working with to start? This is the true midpoint. What we have just found is the formula for the components. The actual midpoint here, it's ugly, but it's just x1 plus x2 over 2. And what was the y component of this? I'm going to change the order of red, but absolutely. Just the average of the x's, comma, the average of the y's. Every single time. Being able to view a problem that seems like it's complicated, and this might seem kind of complicated, it's been a while since you've done it. If you can remember that we can split stuff up into parts or components, things get so much easier. And we're going to use the heck out of that in later chapters. Okay, so here is what I want us to do then. From midpoint and distance, I have a couple problems I'd like us to work. Before we jump into some example stuff that is going to be you do and then we'll talk about, do you have any additional questions? Any part that we've gone through that wasn't clear, that you didn't understand, that maybe I misspoke, or a compliment to give me? Ow. Okay. Example. I want you to consider let's pick a couple points. A, Jermaine, where's point A live that's not the origin? Give me any point that's not the origin. We're making up an example. Okay, so A is 0.67, and B is going to be the point -3 pi. Do we really want to run with pi right away?
Yes. Yes.
-1, I'm fine with. All right, I want you to do two things for me. On A, it's find the length of segment AB. So I'm just going to write that as AB. Find me this distance. That's part A of this problem. And on B, I want you to find me the midpoint. We are going to approach this democratically. If you feel confident in working independently or with your neighbors solving this problem, or attempting it at least, give me a hands up somewhere, like just straight up. If you're confident that you and your neighbors can figure this out, prove it. Okay, go. This real quick. Out of curiosity, and only that, how many of you decided to draw this picture? Cool, awesome. If it helps, I would encourage you to keep doing that. That's great. Alternatively, if you want, and it's the way I would prefer to do it because our math will look the same, we just have a little less writing here. If I just jump right in and name these points, x1, y1, and x2, y2. As I'm looking at this, I know that both of these have an x part and a y part. Here are my x parts. If we're looking for the distance, could you find the length between these? And how do you find a distance of a straight line? Or sorry, a horizontal line in this case.
Just add the absolute values.
Okay, or do the difference and then the absolute value. However you want to think about it, I'm okay with that. From -3 to 6, how far do we go?
9.
You go 9 units, right? And I did that thinking it out in the picture, or I did this minus this and I get 9. So if I just wanted to jump right in, I can say, just by knowing that I need that horizontal distance, it's 9. I'm going to do the square root part of it. AB, the whole thing, is square root of, that first number is 9 squared, right? Plus, what's the distance between the two y's?
8.
And since we're doing a part of a triangle, we do what to it? We square it. Okay. What's this?
81.
Add 4 to it. And add 60 more since you needed to add 64. 145?
Yeah.
Okay. As I'm looking at this, for all intent and purpose, I'm good with this right now.
Okay.
If you had a calculator in your hand, you could give me a decimal. If I was checking to see if you could simplify radicals, we would expand further. But I'm good with this, with the understanding that you should probably talk about length.
Okay.
Okay, we're done. For the midpoint, same thing. I actually like to think about this differently depending if I have the picture in front of me or not. Can you add up the x's? What do they add up to? Try again. 3, right? Because we're not subtracting. It's not minus and negative this time. So when I do x1 plus x2, I'm going to, by default, name my midpoint m, like every time, unless I state otherwise. You guys just said that that was what? 6 x1 plus x2. 3 over 2, so it's 3 halves. There's my x direction. How about the y direction? Which is, so I'll even simplify 6 over 2, and then I'll just go one step further. And now we have a wonderfully lovely midpoint waiting for us. Cool. If you want to draw it, you can. Did I do something wrong? Or did you do something wrong? Do we have a disagreement?
Oh, no, I just hit my phone.
What number do we have different? Sorry, I was talking, yeah, you can't tell. How?
So I did like the x2 minus like the x1 thing, but it was like,
So,
it's midpoint.
yes, but check this out. If you do the, like, you do the difference between them, right, to get the distance. This is a length of 9. So half of that would be how far?
4.5.
Okay, so 4.5 either to the left of the right point or to the right of the left point, if you're thinking about it. So if I have this, you've just determined that half the distance is 4.5.
Yeah.
If I start at -3 and I go 4.5 units till I get to the middle, where do I end up? Like 4.5 is half that distance. If you start here and you go 4.5 to the right, where do I end up? If I go 1, 2, 3, 4.5, do you agree that I'm going to end up at 1.5?
Yeah. Oh!
You just didn't do that last little part where I said you have to add it on from either point. Or, coincidentally, if you start here, here, and you work left 4.5, you also end up at 1.5. Okay, tomorrow we are going to learn how to use our textbooks. Like, not just how to open it and read it, but there's a few examples that I have not shown you, and I've done it for a very particular reason. Tomorrow in class, I'll assign textbooks. We're pretty much done with the section. We'll have a lot of time in class tomorrow to work on homework. Cool. You can keep it. Cool. Take your notebook or leave it in that drawer. Either way, as long as it's here tomorrow, I'm good with it. Video will post to YouTube. Remember, if you're going to drop, it's your choice. Come talk to me if you have questions or anything by Tuesday.